this is the process we are studying. Okay, trying to figure out the Feynman diagrams. So we have defined the single particle states as this B of P like this. So this is the box quantization we have done. Okay. And these states. This is already what we have done. You have the positive state like this. So S is the spin of the particle. Clear? Huh? Okay. So these are the definitions we have introduced in the last lecture. Okay. So you are F. So this is the creation operator for the particle, and this is the creation operator for the antiparticle. Okay. And we have defined then the normal. Okay. So the normalization loop will like this. So you are having B of P prime. Okay. So delta Q. Okay. It's something like 2 pi by Q by V delta Q P minus. Okay. And we have defined this delta 3 P0. So in the box it's defined as V by 2 pi Q. Okay. So this is we have already defined it. Clear? So these are the definitions what we have been doing in the last lecture. Okay. So now if you put P equal to P prime, this will be delta of 0. For delta of 0 you use V by 2 pi cubed, so it is equal to 1. Similarly for the other states. Okay. So then what we have done, okay. So we have calculated how these operators phi plus x on this B state. Okay. So this is the kind of thing. Let's say if you are having the quanta B of k, so this is actually equal to, so you are having some, I have written B here. So what was, okay, so it is something A dagger, let's say, A dagger K acting on the vacuum. So this is a single particle state, this is how we define it. Okay. So I have written B, no, I have written A dagger in the previous definition. Okay, so this A dagger K acting on the vacuum gives you the single particle state. So this is a quanta, or you get quanta of a boson, scalar boson, or you can think it is a scalar particle. Single particle carrying the momentum what? 4. Carrying the momentum k. Okay, so now let's act this phi plus of x at some position x. Space-time point is x. Okay, so let's act this this boson. Okay, and we know this phi plus by Fourier decomposition. So I can write it like this thing: d3k prime by 2 pi q twice omega k prime. So I'll use omega for the energies of the bosons and E as the energy of the fermions. Clear? Okay. So then it is e raised to power minus I k prime dot x. So this is a 4 momentum here. Okay, x is this very objective, and you are having A of k prime. So this object is your phi plus. Because if you remember when we are doing this process, decay of a boson, a scalar boson into fermion anti-fermion pair. Okay, so applying just the Wick's theorem for that kind of process, we arrived actually 3 functions which give rise to non-zero contribution to the S matrix. So what were those terms? So that were actually phi plus, psi minus, and psi bar minus. Is that true? So these are the terms, and I want to actually calculate how this phi plus x on this boson state. Okay. So although I have done it in the last lecture, but let me repeat. Okay. So it will be A dagger k acting on this 0, because this B of k I can write as. Okay. समझ आया? Yes. Okay. Okay. So what this is equal to? So now here, in this very case, what I can use the commutation relation. I know A and A dag. So you are having A dag. Okay, let's say A of K, A dagger of K prime. This commutation is equal to what? Delta 3 K minus K prime. Clear? समझ आया? So it means I can use a commutation here. Okay, so that this A comes in front of this A dagger. Got my point? Once this A comes in front of A dagger, A will annihilate the vacuum. So there will be only the other term, which is with this delta function, which will give you the non-zero value. In other words, I can put it like this thing. Okay, so let me do the complete calculation. 2 pi cube twice omega k prime e raised for minus I k prime dot x. So this I can write as A dagger k, okay, A of k prime, then plus delta 3 this k prime k minus k. Okay, acting on this way. Using that very commutation relation, you are having A dagger minus A dagger. A is equal to delta. You take the other term on the right hand side. Clear? Any problem? Okay. So now tell me. So when this A acts on the vacuum, so I am having this A acting on the vacuum, that's equal to 0. So this term is gone. What remains there? This delta function. Now integrate over the delta. So sorry. Okay. So integrate over the delta function. Integrate over this k prime. What you will get? So this k prime will be replaced by k. Got it? So integration is gone. What are the factors remaining? So this omega k. So it will be like this. Okay. So let me write it here. So in other words, therefore this phi plus of x acting on this single particle or the quanta of the boson. So it gives me okay e raised for minus I k dot x by root of 2 pi cube twice omega k, and there will be that vacuum state. So because vacuum will be there. I have only integrated over the delta function, vacuum will be there. Clear? So this is okay. Now look here, it is actually the single particle state. Single particle states are always what? Since it's actually a free field, is it? So how we describe a free particle? By a plane wave. So is this a plane wave? So you can think the single particle state as a plane wave until it interacts with, until there is an interaction. In the interaction region, okay, so we will be having something different, but it will evolve simply as a free particle state. Clear? And you are having here this kind of factor. Okay? समझ आओ? Any other question? Any question? Okay. So now let's look at, okay, so now, so I can take its conjugate, so which implies the conjugate of this thing. So what is the conjugate of phi plus? So that will be phi minus. Okay? So usually we write this phi as phi plus plus phi minus. So this is the annihilation operator and this is the creation operator. When I take, since this is the annihilation operator, okay, when I take the conjugate, it will become a creation operator. So it will be simply phi minus of x. So what that is? Vacuum state e raised for I k dot x divided by root of 2 pi cube twice omega. Got it? Okay, so now let's apply so let's take the fermion state. Okay, so Muzaffar, let's take our this fermion state EEX. So how you write it? So just to define it. So is there any factor missing? Yes, there is a missing factor because there is one factor. When we wrote this B of K, I wrote it as something A dagger acting on vacuum, is it? But by definition, that's not true. I have put 2 pi cube. So there is actually a factor of V here. So this 2 pi cube will not be there. Okay, so it is okay. So let me do it. This 2 pi cube is not there. It is actually V here. So let me do it here on this. So it is V. So it I'm sorry. Okay, so you have to use that properly. So let me show this factor on coming from this here. So what you are having here? So it is root of 2 pi cube divided by v. Clear? So this is the definition acting on this f dagger s of p acting on the vacuum. So when you wrote this b of k, put what? Root of 2 pi cube by v. Yeah? Samasha in front. So that's why that 2 pi cube will cancel out. So what remains there? Only v. Samasha? Got it? I'm sorry. So now let's act now this psi minus of x on this. What is psi minus of x? Can anybody tell me? Psi minus of x is the annihilation operator for a fermion. So this I have been telling you all the where. Is it true? Okay, so if anybody is still in confusion, so let me write the formula again. So what is our psi of x? So that contains g3 of p divided by root of 2 pi cube. Let me write it for you people. Okay, twice EP. Then there is a sum. S is running from 1 to 2 because two spin components are there. Then you are having this US of p. Then F S of p. Annihilation operator for what? Fermion. And E raised for minus I p dot x. Then you are having B S of p. Clear? Probably V bar. So it is V bar S of p. Then you are having F tilde dagger S of p E raised for I p dot x. So this is a creation operator for what this is. So this is a creation operator for anti-fermion, and this is an annihilation operator for fermion. So you are having a particle and antiparticle in this very state. So this is your psi minus of p. Is it clear? Tisha? Okay. So what is your psi minus of x? Psi minus of x is this very object. Clear? So last time I have shown you this kind of decomposition. You should know it. So what that is equal to that? So let me write d3p prime divided by root of 2 pi cube twice ep prime. So there will be sum. Let's write s prime is equal to 1, 2. So then you are having this s of p. Okay. So have I written correct? US. Okay. Yes. So you are having US prime p, p prime. So this p prime. Then just tell me. So you will be having f s prime p prime e raised for minus I p prime dot x. So it is this very psi minus. Then you are having root of 2 pi cube. Okay, divided by v f dagger s of p acting on the vacuum. Clear? समझ आवा? Okay, now look here. So you are having what here? F and f dagger, and I know this kind of relation. Okay, so this is the relation anti-commutation between f s prime, let's say p prime. Okay, f dagger s p. So what is that equal to? Delta ss prime and delta 3p minus p. Clear? So this is the anti-commutation. Fermionic operator satisfy the anti-commutation relation. Okay? Clear? Okay, so now if I use the anti-commutation here, I will not write this step directly. So take these two operators. When you write the anti-commutation relation in this very case, what you will get? You will simply get, okay, so first this object, delta ss prime, delta 3, p minus p prime. Clear? So you take then f dagger f on this side. Clear? So what will be that? So it will be minus f dagger s p, okay, f s prime p prime. Clear? So in other words, this very objective. So this is equal to simply this f s prime p prime, okay, f dagger s. Okay. So this f dagger is like this. समझ आवा? Okay. So now you are having this very term. This f is on the right hand side. Clear? So f will act on the vacuum. What it will do? It will annihilate it. So that means this term will not contribute. So next, when you do the next step, so this is the only term which is contributing. So there is a sum over s. Okay, so rather sum over S prime. When you sum over S prime, this S prime will be replaced with S. So that means this S prime will be replaced with S. Now integrate over P prime. When you integrate over P prime will be replaced with P. So what we will get? So you do all these steps. So we'll simply get no integration at all. And this 2 pi cube will cancel. So it will be simply 1 divided by root of twice V EP. Okay, USP, then e raised power minus I P dot x, okay, acting on that vacuum. Now you are having a free particle, but free particle, you are having US also here. US signifies it is actually a Sittler, because the fermions are represented by the Sittlers. So, and this is actually, this US is the solution of the Dirac equation. Clear? Okay, so now let's take its conjugate. Now tell me, if I take the conjugate of this thing. Okay, so let's take the conjugate of this thing. So, or let me write this psi minus of x. Okay, E minus PS. So let's take the conjugate. So it will be E minus PS. So if I take the conjugate, what this will be equal to? So take the conjugate of this thing. Okay? So it is our psi minus. If I take the conjugate, what it will give me? It will give me actually, so this is an annihilation operator, it will become a creation operator. What should I write then? What is the conjugate of this psi minus? Is it psi minus bar or psi plus bar? Psi minus bar, yes. Psi minus bar of x. So that's equal to 0, e raised for I, p dot x, u bar sp divided by root of twice v. Clear? So this is our notation. Similarly, if I look at now, is it clear to everybody? Because these are simple formulas, we require them. That's why I am doing it in detail. Okay, everybody has written it? So now let's do. So if I have now this psi bar plus of x, so what is psi bar plus? It is the annihilation operator for positron. Clear? Is it true? Okay. So what you will get on this positron? ES. So you will get simply 1 divided by root of twice V EP. Okay. E raised for minus I P dot x. Then you are having this V bar S of P acting on the vacuum. So which implies its conjugate like this. So let's take the conjugate. So it is simply psi minus of x. Psi bar plus, it will give me psi minus. So I started here with psi plus first. Psi plus, what's the previous case? Psi minus. Huh? I have written no. So that should be psi plus by our notation. So psi plus acts on this electron. I'm sorry. Psi plus, and everything is same. It is psi plus. I'm sorry. So it is psi plus. Okay. So rest is everything. Rest is same. And then when you take the conjugate, that will be psi bar minus. So समझ आओ? Okay. So because we have to be careful in the notation. This kind of notation we have already utilized it in doing the Feynman diagrams. That's why we should stick to that notation. So what that is? Twice dp. So it is a vacuum. E s dot I p dot x vs. Okay. समझ आओ? Okay. So now let's go to our process. At the lowest order, let's try to calculate what are the S matrix elements. Okay. So let's calculate the lowest order S matrix elements. Okay, so that is, what is that? So that is our S1. If you remember, what was our S1? So S1 is something minus IG, G is the coupling constant, okay, and it was d4 of x, okay, psi bar minus of x, psi minus of x, and phi plus of x. Okay, clear? This was our lowest order calculation for the S matrix. Clear? What is the process involved? B goes to E and E minus. Okay. So now let's define. So let's define our initial state. What is our initial state? Tell me. So let's write initial state as I. So what is our initial state? That means the state which is decaying. Huh? So what is that? Boson, scalar boson. So let's take that as this contour B. So let me write it as BK, carrying the momentum K. And what is our final state? So this is our final state. So if I have to calculate the S matrix elements, I need to look actually how this initial state evolves into the final state through this interaction. Clear? Okay. So what is that equal to? So it's E minus PS and E plus P prime S. So let's try. So much sure? Clear? So you can simply say it is like this. It is same thing. You can write it like this. Okay? E plus P prime S prime. Okay? So it is the same thing. It is a compacted notation. Okay? So now what I have to calculate? Now just tell me what I need to calculate. Okay, so what I need to calculate? So I need to calculate this S1, okay, the matrix elements of this first order correction such that I goes to F. So what is that equal to? It is F, S1 and I. So how much is that? Now tell me what is our S1? It is that. So it is I times G. Okay, let me write this integration outside. D4 of X. What is our F? So final state is this electron. Okay. So you are having the positron. So what is our interaction S1? It is psi bar minus of X, psi minus of X, okay, phi plus of X, clear? Acting on what is the initial state? PR. So now you should know, you should understand why I calculated those elements separately. You are having phi plus acting on B and psi bar minus and psi minus acting on these things. Samajh aawa? Clear? So what was the diagram corresponding to this thing? So this was the diagram corresponding to this kind of process. So you are having electron like this thing, and then you are having a positron. Okay. So you are having this as K for the boson. Is this the process what we are considering? What is okay? So this vertex stress is actually the coupling. Okay, vertex of a diagram means you assign a coupling constant to that vertex. So what is our coupling here? So it is G. So I will use actually IG for the time. Okay, for the I will explain these things in a moment. Yeah? Okay. So what I need to calculate then? First I will calculate this S matrix element. Let's try to calculate, plug in the values. So what are the values? Okay, just tell me what are the values. Okay, so let's remove this diagram for the time being. So just tell me what are the values. Minus Ig integral d4 of x. So what is this psi bar acting on this object? Psi minus of x. So there is actually a vacuum state, is it? Is that true? So you are having a vacuum state. Okay, and there will be a vacuum state corresponding to this positron. It will be two vacuums. Vacuum into vacuum. I will call that as only one vacuum. Clear? So this vacuum, so you will be having a vacuum like this thing. Vacuum for the electron, vacuum for the positron. Okay, so you call it as only one thing. Okay, so it doesn't matter. Eh? So much on, it's an invariant object kind of. Okay. So what you are having this psi bar minus and psi minus acting on this thing. So it is something e raised for I p dot x. Let me write those values. Twice v EP. Just keep in mind. So somewhere you are having momentum as p, somewhere you are having momentum p prime. You need to take care of these things, okay? And you are having u s bar p, okay? So psi bar minus acting on this thing, so it gives you this very object. Then you are having psi minus will act on e plus. Just we have seen, okay? So what it gives me? E raised for I p prime dot x, okay? Then root of twice v EP prime. Let me write EP prime here, okay? So much on. And then you are having this Vs of P prime. So let's write S prime as well, because this carries spin S prime, okay? So then what you are having? So this phi plus x on this thing, so it is e raised for minus I k dot x divided by root of twice v omega k, and you are having the vacuum. समझ आओ? Everybody followed it? Huh? Any problem? Okay, good. So what this is equal to now? So now you are, so all these are the numbers, okay? So this vacuum, so there is no operator within, so this vacuum will come, okay, and there will be an inner product between the vacuum, that's equal to 1, because we have taken vacuum to be normalized, okay? So using this definition, vacuum is normalized. So then I can write this very matrix element as okay. So how I can write it? So now tell me minus Ig. Okay, so let me write it for you people. D4 of x. Just tell me. So E is for I. Okay, so let's pick up these exponentials. P. Okay, p plus p prime minus k, is it? Dot of x, because all are carrying the same position variable, okay, space-time variable. Okay, then what you are having? 1 divided by root of twice VEP. Just keep it in mind. Okay, so I will put them like this thing. So that means, okay, so if you look at this very formula, okay, so now look at this very formula. How many particles are involved? 3 particles, is it? I mean 3 external lines are there. Okay, and each external line carries actually, so this is for the electron, this factor, I mean this factor is for the positron, and this factor is for the initial boson, clear? So that means each factor carries, each particle or each external line of the diagram carries these factors. Suppose if you are having n external lines in the diagram, so how many factors will be there? N factors, okay? So, okay, so now what you are having then? U bar SP and you are having Vs prime P prime. Clear? So what this U bar represents? Electron in the final state, and Vs represents positron in the final state. And what is the if there is no such kind of function that represents boson, is it? So there isn't any kind of boson line. Only the factor which corresponds to boson, the initial boson is this factor, and there is no other factor. So you should understand these things because they will help us to build up the rules, what we call the Feynman rules. Okay. So what this object is? So you are integrating over now x. So this will be simply equal to 2 pi raised for 4 because it is in the 4 dimensional. So delta 4 p plus p prime minus. So it will be simply a delta function. Clear? So this, and because there is no other x arising in these factors, you are having only the x in that. That's why you integrate that very thing. So let's write it. Okay. Yes. Others? Okay. So what it is equal to? So which implies S1, the first order correction to the, the first order correction to our interaction process is like this thing. Ig. Okay, so let me put it in the brackets. Then you are having this 2 pi raised for 4. So let's put this also in the brackets. What this delta function gives me? If you see, so delta function gives you actually, if you put its argument equal to 0, that gives us the conclusion. That is the physical result of a delta function. If you put the argument equal to 0, what it gives me? K K is equal to P plus P prime. What does that mean? The initial momentum is equal to the sum of the final moment. That is the total momentum conservation. 4 vector conservation, 4 momentum conservation. Clear? So that means this delta function gives us the conservation law of the entire process. समझ आया? समझ? Okay. So that's why I put it in the brackets. So then I will put like this thing. So let me write this very factor first. Okay, so then I will write this. So what I will do, instead of this Ig, I will put it with this minus Ig, okay, U bar S P V S prime. Okay. Now tell me in this very object. So this is our first matrix element. Clear? Now tell me in this very matrix which are kinematical factors and which are the factors they represent the particles. They represent the process. Now look here, this is simply the overall conservation rule for a process. Clear? So much it has nothing to do with the dynamics. And now look at these things, it has nothing to do with what? Dynamics, because they are kinematical variables. This is simply the volume of the phase space and the energy of the particle. Clear? Do you see any dynamical factor here? No. Is it? And now what you see here? So you are having actually the process which is represented by the particles. Clear? So you are having the factors that represents your fermion and that represents your anti-fermion. Clear? And then you are having a coupling, because ultimately the coupling signifies your interaction. Clear? So G is the coupling. So this very factor we call as the Feynman amplitude of the process. Okay? Got it? So this is known as the Feynman amplitude. So that means I can always write my scattering matrix S element as all these factors multiplied by what? The Feynman amplitude of the process. So in other words, if you need to figure out what is the scattering element of the scattering element of a given process, so you need to figure out the Feynman amplitude, is it? If you know the Feynman amplitude, what you know? Scattering element, okay? And scattering element gives us directly the scattering cross section. In other words, we will see in many processes, you only need to know what is the Feynman amplitude of the process, and it's actually proportional to this differential scattering cross section. Clear? Oh, समझ आया? Okay, so let's go to the non-trivial example. Then we'll set up the rules. So, समझ आया? Okay. So let's go to the another thing. Okay. So what is our non-trivial correction? That is at third order. I will take only one diagram. Okay. So let's take one diagram, because there are many diagrams which are contributing at third order. So that is this very diagram. If you remember, clear? So you are having this boson K and the outgoing electron here, and you are having the positron here. So let's write it as E prime S prime. This is EPS. Okay. So what are these? So these are the propagators. These are two fermion propagators, and this is one bosonic propagator. समझ आओ? याद है? Okay. So let me write what we have done. Okay. So this is our S. So let me write it as 3. Okay. Because the non-trivial contribution comes at the third order of the perturbation theory. Okay. So what that is equal to? So if you remember, it is something IGQ. Okay. Integration over D4x1. There are 3 points involved. D4x2, D4x3. Clear? So what was that? So the contractions of the fields. Okay. So you are having something this phi of x2, phi of x3. So this is the contraction. Then you are having this psi of x2. Okay, psi bar of x3, sorry, x1. So that is the contraction. That means you can take this as x2, this as x1, and sorry, this is x3 and this is x1. Clear? So these are the 3 points. So then you are having psi of x1 and psi bar of x3. Clear? So this is a contraction. Then the ordering of this psi bar, okay, x2, psi of x3, okay, phi of x1. So normal ordering. And this very object is simply what? So these are all numbers because they represent the propagator. So this is simply just we have seen. What is that? Psi bar minus at x2, and then you are having psi minus at x3, and this is phi plus at x1. Clear? You sure? Because we have seen psi bar psi phi, it contains actually 16 terms. Rather 16, eh? So 12 terms. I'm sorry. There are 12 terms in this very extension. Okay? You sure? So out of those, 8 terms, I'm sorry. Because this contains 2 raised for 3. These are 8 terms. Out of these 8 terms, only one term contributes to the process. So that is this kind of term. Psi bar minus, psi plus, phi plus. Okay, and you have to act these on the corresponding points. The annihilation of the boson takes place at x1, and then you are having the creation of the fermion and anti-fermion pair where? At x2 and x3. Rest is actually whatever is in the diagram, those are the virtual particles. Okay, so I will come to those things as well. Okay, so now what I need to know? So I need to know now this thing. So this S3Fi. So how much is that? So that's our E minus. Okay, so let me write first. So you are having a final state, then you are having this S3 and the initial state. So clear? So let's write that. So which implies this S3Fi. So how much is that? So let's write this Ig cube. So this is actually an involved calculation, but straightforward. Okay, so there is nothing, difficult in this. Just put the factors, form of these very factors, you will get what? What you will get? The value of this S3, yeah? Clear? So just plug in the values. Okay, so let's write this integral. So d4 of x1, d4 of x2, d4 of x3. Okay, so now tell me what this object is. Can anyone tell me? It's a boson propagator. How I write that? What is the boson propagator? Sorry, I times delta f, the x, what are the coordinates? Clear? So this is our fermion propagator. I SF x2 minus x1. And this is what? I SF x1 minus x3. Clear? You sure? So these are the propagators. Now let's write these formulas. So it's I delta f x2 minus x3. I SF. Okay, S represents actually we are having a notation. Delta F means the Feynman propagator for the bosons, and SF means the Feynman propagator for what? Fermions. Okay. X2 minus X1 and ISF X1 minus X3. Clear? So then you are having what is the final state? Because these are the operators which will active. So our final state is like this: E minus P S E plus P prime S prime acting on this thing, psi bar minus x2, okay, psi minus x3, and you are having this phi plus acting on x1, and then you are having the initial state here, and you know what this object is now. Clear? So this we have already calculated in the previous process. Okay? So everyone knows so much. Now what I have done, everybody has understood it. So if you have any confusion, just tell me. Huh? Okay. So now let's write. Okay. So let's write the value of that very factor. Can anyone tell me what is the value of that very factor? Okay. So let's do this way. So now if you look, okay, so instead of directly writing those factors, so I will merge many steps together. So this is a propagator defined in the coordinate space, clear? Because it depends on what variables, position variables. These all propagators are defined in the coordinate space. I want to convert them into the Fourier space. The reason being because there is an integration over the coordinates. Clear? I want to remove this integration, the coordinate integration, so that my entire this expression is written in terms of the momentum, initial and the final momentum of the particles. Clear? So, समझ आया? Okay. So for that matter, what I will do, I'll simply convert these very factors to the momentum space. Once I write it in the momentum space, there will be some e raised or something dot x1 like that thing, and you integrate then over these coordinates. समझ आया? So once you integrate over the coordinates, you will be actually getting rid of all these x's. समझ आया? So this is the idea. So what I will do, okay, using momentum. Okay, so transforming propagators into momentum space. So what is how I write? How we go to the momentum space? Anybody? So let's say if you are having this f of x, so I will write the momentum space like this. So d4 of q, because we are in the 4-dimensional space time, 2 pi raised for 4 e raised for minus I q dot x and f of q. So this is the Fourier transform. Samashya? Clear? Okay, so now let's convert them into the momentum space and simultaneously put the value of this very expression. Samajha? I know it is going to be. It's actually trivial. Calculations are trivial; they are not non-trivial. So once you do it on the paper, it is very simple. It is straightforward. So there is nothing. I mean, you have to think conceptually. Okay. So I will provide you the notes. No issues. So you learn these things from the notes. So let's write. Okay. So let's write it. So it's minus I g q. Okay. So then you are having this d4 of x1, d4 of x2. I have been asking department for last couple of years. This thing e raised to minus I q2 dot x2 minus x1. Then you are having I sf q2. Okay. So then you are having d4 of q3 2 pi raised for 4. Then you are having e raised for minus I q3. What is the argument in this very factor? x1 minus x3. Okay. Then you are having this I sf q3. Clear? So now what is the factor corresponding to this thing? Multiplied by anybody? So we have just seen what is that factor. So there will be no that delta function at all because there isn't any kind of those factors. Delta functions will come from here when I integrate over x. So you will be having e raised for minus I k dot. Okay, so what is the here argument? It's xy. Okay, divided by root of twice v omega k. Then you are having e raised for, tell me, I. So what are I myself for I p dot x2. So this very factor divided by, because okay, so it is at x2 and it carries the momentum p. What is in the division? Twice v ep. Then what you are having? E raised for I, probably I or minus I p prime dot x3 divided by root of twice v ep prime. Then there will be the factors that u bar s, okay, p, okay, u bar s t. Then you are having v s prime p prime, and you are having vacuum at that. You sure? Is it clear? Now let's club the terms which contains these x's. Let's club the terms containing x1, then x2, then x3, and then integrate over x1, x2, and x3. Okay. So I can write it as minus I g whole cube. So let's club these terms. So you are having d4. Okay. So let me write these q1, q2, q3 integrations first. So let me write d4 q1, d4 q2, d4 q3. Okay. divided by 2 pi raised power q 4 এটি কোথা গেছে 4 के बाद okay. So then what you are having integration over d4 x1. Let's club the terms which contains x1. So x1 contains, this is the factor containing x1 and the other one, okay, and this is the term which contains x1. So what you are having, e raised power when you say minus, so it is I q2 dot x1, clear? So let me write I q2. So then you are having minus q3, okay, then you are having minus k dot x2, clear? I have put I outside and x1 outside. Then you are having integration over d4 of x2 e raised power. So now x2, so this is the factor containing x2, I minus I, let me write. So you are having q1, then you are having, this is also containing the minus, that minus I have put outside. So plus q2, okay, then you are having this very factor, so it is plus already, plus p dot, sorry, minus, so it will be minus x2, clear? Then you will be having a factor g4 of x3, okay, so this is the factor, so it is e raised for I q, okay, so it is I q1, then you are having here plus q3, then you are having plus p prime dot x3. समझ आओ? So these are the factors. Now what remains there? So then you are having this I delta f q1, then you are having I sf q2, then you are having I sf q3. Clear? So what remains there else? So all these factors, 1 divided by root of twice v omega k, 1 divided by root of twice v ep, 1 divided by root of twice v ep prime, and you are having then u bar s p, okay, v s prime, okay, and still if you see, okay, now look here, you are having these kinematical factors arising, and then you are having again what, the functions for the external fermions, fermion and antifermions, and you are having at the third, how many vertices you are having? I assigned minus ig for one vertex. How many vertex you are having here? 3 vertices. You are having minus ig cube. Clear? So all the things, so these integrations, so this will give me actually overall conservation in the process. Okay, so now let's integrate them. What this will give me? So this will give me actually 2 pi raised power 4 delta 4 q2 minus q3 minus k. Clear? So this will also give me a delta function that will also have and with 2 pi raised power 4. Clear? So that will cancel with this thing. So 2 pi raised power 4 will be 3 times. So that is 12. It is 2 pi raised power 12. It will cancel out. Clear? So now let's write those things. So let me write first delta functions. So then let me write the delta functions. So what are the delta functions coming up? So the one delta function, it is delta 4 q2 minus q3 minus k. Clear? So then you are, because they are all in the product, delta 4 q1 plus q2 minus p. Is it? Then what is the delta function coming? Delta 4 q1 plus q3 plus p prime. Okay? Okay. So now let's write that. So what I will do, so you can consider this as entire function. So like this thing, you are having delta of x multiplied by f of x. What is that equal to? Simply delta of x and f of 0. So put the argument here. Clear? So it means, so in other words, you are actually doing the integration over x. Not the, okay, so when you put the integration over x, this will be 1, you will get f of 0. Clear? So it means, so what I will do, now let's put q2, okay, or the value of q3. Let's put the value of q3 in this very delta function and the value of q1 in this delta function. Clear? So what I mean by that, so you keep these two delta functions as set minus k, then you are having delta 4 q1 plus q2 minus p. So here I will put what is the value of q1. Now figure out what is the value of q1 here. So it is minus Q2 plus P. Is it? Now what is the value of Q3 from this very delta function? It's plus Q2 minus K. Then you are having plus P. Is it? So much now what you get? So this Q2 and Q2 cancels. So let me write it. So it is delta 4 Q2 minus Q3 minus K delta 4 Q1 plus Q2 minus P. What you are having here? Delta 4. Okay, so you can take, okay, so I will write P plus P prime minus K. Clear? Can I write it? So now tell me, is anywhere P prime K? So this is a delta function which contains actually external momentum, is it? So what is it gives me? It gives me P plus P prime is equal to K. It gives me the overall conservation. So that means out of these three delta functions, one delta function corresponds to what? A conservation rule. So and it does not depend upon the internal momentum. I mean the internal line, the momentum defined on the internal lines. Clear? So you can pick out this delta function and put outside. So okay. So now what I can do now? So when you pick out one delta function, how many are remaining? Two delta functions. So let's integrate over Q3 and integrate over Q2. Okay? Because you are having only two delta functions, let's integrate over Q2 first. Okay? So that means in this very expression, Q2 will be replaced by what? Q3, let's say Q3 plus K. Or Q2 plus whatsoever. Or you can okay, instead let's integrate over Q1. Forget about Q3. Let's integrate over Q1. Q1, wherever you are having Q1, Q will be replaced by what? Q2 minus P. Then you integrate over Q2. Q2 will be replaced by the same, the other part. Clear? Okay, so let me write it. Okay, so let me keep it as such. So integrate now. Okay, so first, okay, so what you do, integrate over Q1 and Q2. So let's do it this serially. So what you will get? So this S3 Fi, so I will get as minus Ig cube. Okay. So this 2 pi raised power 12 will go, huh? Because I have told you each factor will give me what? 2 pi raised power 4, huh? Okay. So I will take that very delta function now out. Delta 4 P plus P prime minus K. समझ आओ? So now let's integrate over Q1. What is the function that depends on Q1? So it is this very function, is it? So I will write it as d4 of Q3 because I am integrating over Q1 and Q2. Okay. So let's write. You are having I delta F. What is Q1? So let's write Q1. Q1 will give me P minus Q2. समझ आया? So let me write Q2 and D4 Q3. So let me keep these things. So ISF because it will be simply Q2, then ISF it will be Q3. So let me keep this step. So then you are having this very factor. Okay. So this factor comes here. So it has nothing to do with this integration. So समझ आया? So you put this factor here. So now integrate. Okay. So there is a delta function. So there is a delta function. This delta 4 Q2 minus Q3 minus K. Because I integrate only over this delta function. So समझ आओ? Okay. So it is simply the business of this delta function. Now let's integrate over the other delta function. Okay. So it is minus Ig cube. So it is delta 4 P plus P prime minus K. So integrate over now Q2. So I'll be having only integration over Q3. So integrate over Q2. So I delta F. So this Q2 will be replaced by what? Q3 plus. So it is P minus, just tell me, Q3 minus K. Clear? E? Okay. So then you are having I SF. What is this Q2? Just tell me. Q2 is equal to Q3 plus K. Then you are having ISF Q3. So let me write these factors. Now, so 1 divided by root of twice V omega K. Okay, like this, root of twice V EP twice V EP prime. Then you are having u bar s of p v s prime. Clear? Okay, so now this is our, okay, look at this way. So what I will do, I will put a, okay, so I will put a 2 pi raised power 4 here, and I will divide this as what? 2 pi raised power 4. समझ आओ? So now look here, what there is something, an integration factor pops up, is it? In the previous case there was no integration factor, is it? So समझ आओ? You are having everything the same way, the Feynman amplitude, what we have defined, the kinematical factors, and there is something integration over all these momentas. Why these momentas are? Okay, now look at what it means. So you are having this kind of diagram. Okay, so bear with me. So what is the momentum here? It is P. What is the momentum here? It is P prime. What is the momentum here? It's K. Now let's look at these very arguments. Where is the momentum? This contains the momentum P minus Q3 minus K. What is the other factor containing? Q3 plus K. Is it? What is the other? It is Q3. समझ आओ? Now let's look at each vertex. So you are having an overall conservation of the momentum. So now look here. So you can say Q3 as Q, because it's a dummy variable. Okay? समझ आओ? So what it means? It means, so when you are having a loop, so you have to assign momentum by yourself on one of the arms of a loop. Then at each vertex, make sure conservation holds. Okay, so what is the momentum here? P prime. So that means you are distributing the momentum in on these two lines. Now let's sum out them. Q3 plus this thing. What you will get? You will get actually P prime is equal to P prime minus K. Is it? So that means on this vertex, what is happening? P plus P prime is equal to K. Is that true? So the momentum conservation holds. So now let's look at this very vertex. Q3. So there is some. So one will be minus Q3 something. So we need to look at it. So these two will, they should cancel. One, it should be actually what? Oh no, it is okay. K and K cancel. So you are having Q3 again, is it? So whatever the momentum is, okay. So the momentum here is Q3, is it? So is it okay? So you can, okay. So now let's look at this thing, this very vertex. Okay, so what is the vertex here? Huh? So I think it should be minus Q3 on this very side. So that if you add these two, if you add, you should get this one. And this one should be minus. Okay, so this should be minus. So somewhere we are having an error in the delta function. This should be minus. So when you add, you will get K. So now let's look at, you add the two because the direction is this way. So this is the direction of the arrows, is it? समझ आओ? Oh yeah, it is okay now. If this is the direction of the arrow, so what will be this thing? So no. It is in the same direction. So it has to be minus. So just check it. It has to be minus. So now let's look at here. So Q3 plus this thing. Q3 and Q3 goes. So what you will get? Minus K. Because ultimately, what is happening? So let's check it up because we are already late. So let's check it tomorrow. Let's stop here.